probably should, but who might have?
Thank you, Lindsay. Okay, today we are doing inverse trig functions. It should be very short. These are all the notes that I have for you. Yeah, 5 questions. So we have already worked with inverse trig functions formally. What we're going to do now is we're just going to use them in a different way. So as a review, inverse means that if I take, oh wait, I have that. The output and plugged it into a function, it would give me whatever my input is. So if f of v equals u, then my inverse with u plugged in would give me the initial input v. That's what the inverse is. So it reverses your domain and your range. For trig functions,
What's the f in the middle?
If and only if. For our trig functions, that looked like if sine of theta gave me k, then sine inverse of k gives me theta. So was given the ratio, find the angle that makes it true. That's what we looked at it as in context of trig functions. It is also important to note that if I'm working with inverses, if I take an inverse and plug it back into the original function, my answer is going to be whatever the input value was. So an inverse and an original cancel each other out, leaving just the answer as the input value. The same thing applies if I went the opposite direction and plugged an original function into an inverse. It would still just be equal to whatever my input value was. So inverses kind of cancel each other out, if you will. So what we're going to be looking at today is we're going to be looking at inverse trig functions plugged into original trig functions, and then originals plugged into inverses. So it's just going to be kind of fun. The first example I would like to look at is to solve cosine of arc cosine of -1/2. Yeah. Okay. We did write this down. We wrote down our original inverse trig functions. Arc cosine is the same as cosine inverse. So this could also be written as this. There are 2 ways that we could solve this. One of them takes a little bit longer than the other way. The first way is that we could find the cosine inverse of -1/2, as in find the angle or angles that make that true, and then plug those back into this cosine function. Or we could recognize that these two are direct inverses of each other because they are the same trig function, but one of them is an inverse, which means they cancel each other, and the answer is just whatever my input value was. So cosine of cosine inverse of -1/2 just equals -1/2.
So the inside and the outside are different.
If the inside and the outside are the same, they cancel. If the inside and the outside are different, they cannot. And we'll have to do it the long way. These two are the same because they're both cosines, just one of them is an inverse.
Okay, so they're inverse of each other. That's right.
Yes. Yes, they cancel. So again, 2 ways we could have solved this. We could have found cosine inverse of -1/2, which means we would have used the chart on the back of our unit circle, found the angle that made this true, and then plugged it into this cosine function and gotten our answer. But since they were the same trig function, but one was an inverse, they canceled, leaving just the input value as my answer. Does that kind of make sense? So we're going to do more examples, obviously, because that's kind of hard to wrap your head around.
Cosine inverse is just like cosine of -1/2, and then you flip it upside down.
No, that is find where cosine equals 1/2 and find the angle that makes it true. That's what this is, though. And then I would take this angle and plug it into this function. Let's do an example where we use that, and you'll see what I mean. So this is going to be example B. This is sine of arc cosine of negative square root of 2 over 2. Unit circle, yes.
Arc always means
Arc always means inverse. So this is the same as sine of cosine inverse of negative square root of 2 over 2. And we're going to assume that we're using an angle from quadrant 3 on this one. So what I'm going to do, I'm going to do this inside part first. And I'm going to find the angle where cosine is equal to negative square root of 2 over 2. And it has to be an angle that exists in quadrant 3.
How do we determine?
Because I told you it's quadrant 3. It will tell you.
You want the what?
I want the angle in radians, because that's what I prefer, where my output or my answer is negative square root of 2 over 2. Once you have it, put your finger on it and check with the person next to you.
So every time we're going to do this, you're going to tell us.
I'm going to tell you what quadrant, yes.
You're going to tell us you don't want to go into this direction, or are we just going to know?
Probably not.
So if you give us one
Yes.
Is it gonna be like the
Check your
density greater than the less than?
Yeah, it'll give you some indication of what quadrant you're in. Yeah. Okay, Ray. What angle is cosine equal to negative square root of 2? That's in quadrant 3. Are you still looking?
Yeah.
Okay, I'll give you a second. I'm sorry, I didn't mean to call you out like that. I'll give you a second.
Would that change the sign?
Sine is negative. No, because it's going to be an angle that we're plugging in. It's going to give us an RB negative. Did we find it? What is it? Okay, everybody. What was it again, Ray? Okay, so she solved this part, and she told us that cosine inverse of negative square root of 2 over 2 in quadrant 3 is equal to 5 pi over 4.
So it doesn't matter that it doesn't matter.
That it's what? No. Well, it just means that we had a ratio and solved for the angle. That's all inverse means.
I thought it did.
So now, hold on. We've done trig inverses before. That is not new. We've done them a lot.
Why aren't we using secant?
So what we're going to do now is we're going to take this 5 pi over 4 and we're going to replace this whole parentheses with that. So then this just becomes sine of 5 pi over 4. And then I use my circle, unit circle again, go to 5 pi over 4 and figure out what my sine value is. It should also be negative square root of 2 over 2. So my final answer would be negative square root of 2 over 2. They won't always come out to be the same thing. That just happened that it was an over 4 angle. So sine and cosine are the same there. We solved this part for the angle
I understand what
Why are
you
you
did.
using cosine? I thought it was.
I don't understand why.
because it's cosine inverse.
Like, you're not paying attention to the inverse, so you're just going to cosine.
Yeah, we looked on our cosine column for where cosine was equal to negative square root of 2 over 2. There were 2 angles. I found the one that was in quadrant 3, and then that's the angle that I replaced this with. Inverse finds angles. Normal trig function plugs in an angle and gets an answer. So I worked backwards here to get the angle that I then plugged into the outside function.
What we're thinking of is we're taking the inverse literally. Like, why are we flipping cosine and secant?
Oh, okay. No, those were reciprocals, not inverses. Yeah, inverse solves for angles, which we then plug into the outside function. Reciprocal is like secant and cosecant, not secant. Sine and cosecant, or cosine and secant. Those are reciprocals. They're not the same thing as inverses. Like, be very careful with that terminology. Does this kind of make sense? Solve for the angle, plug the angle in, got the answer. These two will not always be the same if I have different trig functions. Just for this angle, they turned out that they were.
Great question.
Yes.
So if we're doing it and we go down, can we just go over? We have like.
No, you can do it all in one step if that works for you. Yeah, I'm going to do it like this because if you want to go back and look at it, it might make more sense.
Yeah.
But you can definitely, once you realize it, do it yourself. Okay, so let's do example C. What's my answer for this one? How did you get that? Because they're the same. Both of these are sines. This one is an inverse, so they cancel, leaving just the input value as my answer. Do we all see how that one worked? Okay, so you don't have to go through all the work if you recognize they're the same trig function with one being the inverse. Example D. So this one is the same idea as example B that we did, but it's kind of in reverse order. So this time I'm taking the cosine inverse of sine of negative pi over 6. My process is still the same. I have to solve the inside first. So that means on my unit circle or on the chart on the back of my unit circle, I'm going to go to the angle, negative pi over 6, and I'm going to figure out what my sine value is. What is negative pi over 6 equal to? Because that's definitely not on our unit circle. Say it again, honey. 11 pi over 6, or we have a negative angle identity that says anytime I'm taking the sine of a negative angle, we just put it out front and make our answer negative. We did that a while ago. So you take 2 pi and you subtract pi over 6 from that, leaving us at 11 pi over 6. Oh my goodness.
Yes. Thank you.
Wait a minute. The game's confused. No, I'm confused. Is that the same thing as just taking pi over 6?
And making the answer negative, yes. Okay, so it was negative pi over 6, which is not on our unit circle. I know positive pi over 6 is here, right? So I started here and went up. Negative pi over 6 just like says I go the same distance in the negative direction. So I just go down, and I find the angle that is pi over 6 below my 0 or 2 pi angle. And that's going to be 11 pi over 6. So then I need sine of 11 pi over 6.
Could you use pi over 6?
Yes, just make the answer negative. So what's it going to be? Negative 1/2. So that means I'm going to replace this whole parentheses with negative 1/2. And then I'm going to find the angle where cosines equal to negative 1/2. I did not give you a quadrant, so now I want both angles. Yes, ma'am.
So you would just move the negative sign, negative in front of the sign,
Yeah, this is the same as this.
and then just solve it. And they answer.
Yep. Same
Or
concept.
go half.
You go pi over 6. And the sine of that is 1/2 positive.
I thought
Yeah.
we were doing like that.
No, nope, that just came from my unit circle. What angle or angles give me a cosine value equal to negative 1/2? I want radians.
Pi over 3 and 5. Wait, no.
I didn't think that sounded right.
Well, yeah, it's all on one.
And
4 pi.
there you go. So since I didn't give you a quadrant, both of those would be your answers.
Wait, what did I do? Wait, how did you do that?
Do what?
Those are both positive. Oh, I need it.
Yeah, we needed a -1/2. Do we see how this is happening? Anybody super confused still? We have a couple more examples and we're done. No, we're okay? Okay, let's do another one. Alexa, what's the answer to this one? 1,000. How did you get that? They cancel because they are the same trig function, just one's an inverse, and then what my input was my answer. We okay with that? Awesome. We're going to do one more and we're done. Marissa.
Will there always be
In one of these, yes. Because you have to. That's the only way it works. Last one. I would like secant of arctangent of 1, and I'm looking in quadrant 1.
Is this the same thing as parentheses?
the one?
Like, how much you have, like, yeah, the one.
You just don't have double parentheses.
Like, if you
Do
scroll
I
up,
need double parentheses around the one?
I don't know, that you've been writing them and now you're not.
It just, they can be either way. This is the same as, which is technically the same as this.
No, that's not the same problem, no. Yeah, okay, so it is.
They're all the same thing. Yeah.
Just one.
Different like textbooks, different problems. They're not necessarily going to put parentheses here, but you should know that they exist. So yes. Who can tell me what I'm going to do first on this one? Nadia, awesome.
First find tangent.
Okay, so where does tangent equal 1 in quadrant 1?
At pi over 4.
Awesome. So what am I going to do with that pi over 4?
You then find first secant equals on the pi over 4.
Perfect. So then I take that pi over 4, plug it into my outside function that is the secant, and I go to the angle pi over 4 and figure out my secant value. What is it?
Square root 2.
Anybody get something different? Does that make sense? Okay, that's all you're doing today for your homework. So that is the end of the notes. There are 5 questions on your homework. If you have a question, let me know.
How many letters are there?